Okay, so would water have ever rotated on this rotating sphere when the supposed, the planet got spinning, right? When it was first big banged into existence? Well, here I have a pot of water, and actually has more friction than the globe because it's got friction below and it's got friction on the sidewalls. Okay, so I'm going to put in this green dye and we start to spin it. So you can see the dye is not turning. That's in the water. The water's not moving. It has two reasons that the water would move: friction and surface tension. Well, surface tension is not going to come into play. And friction, it's only when the dye sinks to the bottom and you see a little bit of friction at play, but the rest of the water is not going to turn. When they say gravity, well, I'm on the gravity ball. Let me repeat, I'm on your gravity ball doing this experiment, and it's not forcing the water to turn, right? Because the green dye is not moving and the ground is rotating out from under it. And here I'll do the same thing. I put some dots on the bottom, scribbled some black marker so you can see the ground turning from underneath the green dye. And just a reminder, that's thousands of feet deep water moving at hundreds of miles per hour, and the water wants to move in a straight line. So does the air, but the ground is forcing it to turn. All points on a sphere are forcing it to turn. And of course I have the AE map here so you can see the whole Earth and see all the water, and you can see the ground rotating or turning out from under the water. Would the water have ever gotten turning with the rotating sphere Earth? So what's going to make the water turn with the rotating Earth? Well, actually, never mind what's going to make it turn. What's going to make it even move with the ground? The ground is going to have to drag the water along, right? So what's going to get the water, when is the water going to get up to speed with the moving ground, the rotating ground? Well, let's say it does happen. Well, at that point, the water's going to move straight. Is going to want to move straight. That's what any free moving thing, water and air and anything not tied down, is going to want to move in a straight line. And that takes it to the equator. That's what we see with rotating, spinning balls. And as I've said many times, gravity located at the center of mass aids in things going straight, just like satellites. The concept, the fictitious concept of orbiting satellites. They move in a straight line, because they orbit the center of mass. So that's why water and everything is going to want to move in a straight line. And that's Newton's observation, right? That we see on our flat Earth. Everything moves in a straight line. So what's going to make the water, first of all, even get up to speed? But let's say it does. What's going to make it turn? And let me remind you that all latitudes on a rotating sphere Earth are a turn, to the left in the northern hemisphere and to the right in the southern hemisphere. So the water and the air want to go straight, even though the ground is turning. So in order to see a scene like this, like a mirror, like glass, you have to have the water and the air has to be in sync with the ground. Otherwise you get turbulence, either wind or waves, and a centripetal force is required to make something turn, to go in a circle, to circle. So what's going to do that? Remember, I did this experiment with the little blue ball. I had to make a very small drop of water or dye. I put a very small drop so that it has enough friction and surface tension to keep it turning, so I can get up to speed. And once I do get up to speed and the drop of dye can break free from the friction and the surface tension, it heads south toward the equator in a straight line, as per Newton's law. Or just, actually, it's just a hijacking of what we observe. Things go in a straight line unless there's something to act upon them. Now, a truth is what this professor says, that in order for something to turn, to remain turning, it needs a force.
And one other experiment we can do to show that a force inward is required to keep the ball moving in a circular path is to, at some point, as the ball is rolling around there, I'll just pick up the ring and watch what happens to the ball. The ball will be moving in this path. When the ball is right here, I'll lift up the ring, and you'll notice that the ball will continue on with a straight line motion in the absence of a net force. demonstrating that a centripetal force or an inward force is required to keep an object moving in a circular path.
Okay, called centripetal force, or an inward force. Okay, so there is no inward force to make this water turn with the ball. It'll want to go straight, as I show with this blue ball and this car. On the blue ball, you see the car, that's a straight path. The latitude lines are a turn. All points on a sphere are forcing the ground to turn to the left in the northern hemisphere and to the right in the southern hemisphere. The only place you go straight, and this is talking about on a sphere, a straight line on a sphere is a great circle, and that's the equator. Now, as you move toward the poles, it morphs from the action on the equator is like a Ferris wheel, right? You go up and around, but you, as far as left to right goes, you move in a straight line. As you move toward the poles, you start to morph. The Ferris wheel morphs into a merry-go-round. So when you go all the way up to the North Pole area and you stand on that surface, you are essentially on a merry-go-round. Very slow-moving merry-go-round, but you're on a merry-go-round. That's the confusing part. How a sphere works is that you got to think of them a morph. It morphs. So the upper, toward the poles is a platform, but it's a convex platform. It's not a flat platform exactly like a merry-go-round would be, or like my blue platform here rotating. But the principle applies. And gravity has no relevance as far as making something turn. As you can see, I'm on the ball right here, and I'm turning this pot, and the water's not turning. Even though friction's at play. Not just the ground, like you'd have on a sphere in this pot. You have the ground creating friction, but you also have the walls of the pot creating friction, and yet it's not making it turn. So the ball is fiction. You realize it was made up, right? It was made up to counter the biblical account, which is that God created. And they don't want that, right? So here you go, just another experiment and another proof that the water wouldn't turn with a rotating sphere. And if it ever did eventually get up to speed, well, not even that the water won't turn. So here's another proof that the water won't even move on a rotating sphere. Once the ground's going to rotate right out from under it. And essentially what that causes then is hundreds of mile per hour moving ground with water not moving is the same as the water moving backwards at hundreds of miles per hour relative to the ground. So that's a catastrophe. And if it ever does get up to speed and start spinning with the ground, it's going to want to shoot out in a straight line. That's why water moves to the equator of a spinning ball. All right. That's it for now. We'll talk to you soon. Bye.